Hello and welcome to our day 2 notes. Today we're talking all about adding and subtracting, multiplying and dividing fractions. And kind of our overwhelming goal here is just to be able to do these things. But when we're adding and subtracting, that's the first thing we have to do. We need a common denominator. Remember, in a fraction, the denominator, that's an O, the denominator is the number on the bottom. So we need that number on the bottom to be the same, and then we add or subtract the numerators given that denominator. On our first one, we already have common denominators. So we put that denominator on the bottom, and on the top here we'll have 5 plus 5. So that gives me 10/6, and technically we should reduce that since we can. We can divide both the top and bottom by 2 to simplify this fraction. 5 over 3 is our final answer. I would technically accept either one of these. You did the bulk of the work. The other part is just the simplification. In adding and subtracting, even multiplying and dividing, some teachers will tell you that this is not a very good fraction representation because your numerator is bigger than your denominator. I have zero problem with that. Technically, this is called an improper fraction. I am totally fine with improper fractions. Okay, there's nothing wrong with this answer. If you wanted to clean it up, I guess you could say that it's 1 2/3, but that's just an extra step that I don't see being completely necessary. So what is the best common denominator for the next one? One thing I could always do is I could always multiply these two together, and in this case it would give me 16, and that's always a viable common denominator. It's not always the best one though. In fact, what I have to ask myself is, before I get to 16, is there any number that I can turn both these denominators into? And there is. I can turn them both into 8. Okay, and the way I do that, I have to use multiplication or division. So I have to ask myself, what did it take to turn 2 into 8? To turn 2 into 8, I had to multiply by 4. So I'm going to do that same thing on the top, and I'm going to multiply by 4, multiply the 1 by a 4. 1 times 4 is 4. And then I have to ask myself, well, what did I do? Let me thin this down a little bit. What did I do to turn 8 into 8? Well, I didn't do anything. It's already 8, so we're good. So then I'll do that same thing with the 5. Instead of multiplying it by something, I just get 5. So my final answer will be 4 plus 5 over 8, or 9 over 8. Okay. All right, for my next one, I can kind of follow the same process. I could always use 4 times 8 as a common denominator, but there's an easier one. There's a couple easier ones. I can turn both these into an 8, so that's what I'm going to do. To turn 4 into 8, I multiply by 2, so let's multiply 3 by 2 to give me 6. The minus comes straight from this minus right here. So 6 minus. How did I turn 8 into 8? Just nothing. It just is. So there we go. 6 minus 5 is 1, so my answer is 1/8. And then for the next one, there is no good way to turn 5 into 12. Or in fact, there's nothing really that I can do until I get to 5 times 12, which is 60. Okay. So how do I turn 5 into 60? Well, I multiply by 12. So I'll take 4 and multiply it by 12. 4 times 12 is 48. And then, how do I turn 12 into 60? I multiply by 5. So how do I turn 11 into something over 60? I'll multiply it by 5. And 11 times 5 is 55. And when I do that subtraction, I get negative 7 over 60. And that's my answer. Go ahead and pause the video there and do the next 4 problems. Okay, hopefully you had a chance to do that. Just as a recap, excuse me. The first one already had common denominators, so I just subtract the numerators. 3 minus 7 is negative 4. The second one, I can make it a common denominator of 9, and the way I do that is keep the 4 the same, but I have to multiply the 2 by 3. 2 times 3 is 6, so I get 4 plus 6 over 9, which is 10 over 9. The next one's another one of those that there was no common denominator before we get to the 2 denominators multiplied together. So the best one I can get is 20. And then I had to multiply both of those. So how to turn 4 into 20, multiply by 5. 7 times 5 is 35. How did I turn 5 into 20? I multiplied by 4. So 1 times 4 is 4. And I get 39 over 20. Last one, I could use a common denominator of 4. And how do I turn 2 into 4? I multiply it by 2. So 3 times 2 is 6. 6 minus 7 is negative 1 over 4. Okay? So that's the idea on just how to add and subtract just fractions. For mixed numbers, I'm actually going to skip that for right now. This was kind of put in the wrong order. But we're going to talk about how to turn mixed numbers into improper fractions first, because that's actually going to be my first step of adding and subtracting mixed numbers. So if I have a mixed number, let's say I've got something easy, and I want to say 1 3/4. Because I don't think that is one of them that I'll do up above. So maybe let's use 1 4/5. Just change it up a little bit so that I'm not doing all of the work. 1 4/5. To turn this into an improper fraction, this right now is a mixed number. Okay, there's a whole number and a fraction part. Okay. The way I want to do that is I want to start at my denominator and know that whatever improper fraction I get is going to have the same exact denominator. I'm not actually changing the denominator, but I'm going to use the denominator to figure out what my numerator is. And I want to take denominator times the whole number, and then whatever I get there, I want to add that to the numerator. So we can think of like denominator times the whole number plus the numerator. And for us, it's going to be 5 times 1, which is 5. 5 plus 4 is 9. So 9/5 would be the same as 1 4/5. Let's look at a couple examples of that. So I know that whatever I'm going to get here is going to have 2 as a denominator. And I want to take 2 times 5, which is 10, plus 1 is 11. So I get 11 halves. I don't know why I wrote those lines so big. Okay, this is another one of those that little bar there isn't supposed to be there. It's just a formatting issue when I copied these problems over, so go ahead and ignore that. But this problem brings up a weird thing, and there's this negative sign out in front. And for now, I just want to know that it's there, but I don't actually want to use it. And I'll talk about why in just a second. So I'll do the same thing. I'll have 7 as my denominator. 7 times 7 is 49, plus 4 is 53. and then I want to remember that negative now. Okay. So the problem that I see with students, what they do in a case like this is they'll go 7 times -7, which is negative 49, and then when they add 4, they get negative 45, and that's not the same thing as -7 and 4/7. So that's kind of where an issue comes in, and you want to make sure that you take your time and do it right. Okay. Go ahead and pause the video here and try the other two. Okay, hopefully you had a chance to do those, and hopefully what we get is, for the first one, again, I kind of ignore the negative for now. 3 times 3 is 9, plus 2 is 11, so it's -11 over 3. And then this one was a little bit tougher just because the numbers got kind of large. 8 times 14 is 112, plus 7 is 119. So 119 over 8. So that brings us back up to how to add and, how to add and subtract mixed numbers. The kind of steps we want to follow are as shown. The first thing I want to do is go mixed numbers, and I want to take that into improper fractions. Okay, that's the first thing that I want to do. Let me resize this a little bit. So that's the first thing I want to do. Step 2 will be find common denominators. Step 3, add or subtract. And step 4, simplify, if necessary, or if needed. So those are kind of my 4 steps to adding and subtracting mixed numbers. Let's go and see that in action. So for the first one, I want to turn it into an improper fraction. That's the first thing I want to do. 4 times 2 is 8, plus 1 is 9. So the better you can get at that process, the quicker you can get at it, the better off you're going to be. 6 times 1 is 6, plus 5 is 11. And now we've just turned it into a problem just like up above. I want to find common denominators. And let's say that I think 12 is the first one we can get, because 4 times 3 is 12 and 6 times 2 is 12. So since it was 4 times 3, 9 times 3 is 27. And since it was 6 times 2, we'll go 11 times 2, 22. And we get 49 over 12. The next thing I want to do on this one, I want to do that same idea. 4 times 1 is 4, plus 3 is 7, so this is 7/4. Now instead of plus 4, I want that to have a denominator of 4. And so how would I do that? This is like 4 and 0/4. And so how would I use that same idea of mixed numbered improper fraction? 4 times 4 is 16, plus 0 is still 16. And if we check, 16 over 4 is in fact 4. And 7 plus 16 is 23. So we kind of made our common denominators and went whole number to improper fraction at the same time. So that was kind of nice. For the subtraction ones, same idea. Nothing really changes. 5 times 1 is 5, plus 4 is 9. So I have 9/4 minus 3 1/2. Sorry, 9/5. Yikes. Good catch. 2 times 3 is 6, plus 1 is 7. So 7/2. And I need to find common denominators. I think 10 is our best bet. 5 times 2. So 9 times 2 is 18. 2 times 5 is 10, so 7 times 5 is 35. So when I subtract those, 18 minus 35 is negative 17 over 10. And that's what I get for that one. This last one here, I have 15 and 1/2, so that's going to be 2 times 15 is 30 plus 1 is 31 halves. Minus, I'll do the same thing. I want it to be something over 2. And so the way I do that is 2 times 3 is 6. So 6 over 2. And we have our common denominators. 31 minus 6 is 25. So 25 over 2 would be our answer there. Okay. Let's go ahead and turn the page and let's look at multiplying and dividing. First off, multiplying. I want to kind of follow the same procedure as before, but when I multiply fractions, I multiply straight across, top times top, bottom times bottom. So 5 times 5 is 25, and 6 times 6 is 36. And I can't reduce that, so I'm good to go. Whenever I have a negative, I kind of think of that negative as being in the numerator. It just kind of helps me out a little bit. But other than that, I'm going to do the same thing. Negative 1 times 5 is negative 5. 2 times 8 is 16. Again, go ahead and pardon this thing here. It's not really there. So for this one, I have some mixed numbers, and what I want to do on these is I want to start off by getting rid of my mixed numbers. And that process, just turn them into improper fractions, same as before. So 5 times 1 is 5 plus 4 is 9. So I have 9/5. And times 3 times 2 is 6, plus 1 is 7. 7 halves. 9 times 7 is 63. 5 times 2 is 10. Okay. So using that idea, we can kind of fill in our steps just like before. Let's go ahead and do that. So what I want to start off with is mixed numbers to improper fractions. And then I want to multiply straight across. Kind of meaning top times top and bottom times bottom. And then simplify if needed. Wow, simplify if needed. Okay? So that's my method for multiplying fractions. This last one here, every whole number I can think of as a whole number over 1, if that helps. I know in the previous page when we had that, I went ahead and made a special denominator that helped me out with my problem. But when we're multiplying, we don't really need a special denominator. So I can just use it as negative 3 over 1. This one, numbers get a little bit big, but negative 31 times negative 3 is going to give me 93. And on the bottom, 2 times 1 is going to give me 2. So not a bad problem, and didn't need to be simplified. Go ahead and pause the video, give the next 4 problems a try. Okay, hopefully you had a chance to do that. And in the first one over here, I had negative 3 times negative 7 is 21. 11 times 11 is 121. The second one, negative 4 times 2 is negative 8. 9 times 3 is 27. Okay, so we're going through these kind of quick, and just because it's just straight multiplication. We're multiplying the top by the top and the bottom by the bottom. The next two, I have some mixed numbers to deal with, so I turn them into improper fractions. 2 1/4 is 9/4. Negative 1 5/6 is negative 11/6. And so that gives me negative 99 over 24. That would be an okay answer, but I should divide both the top and bottom by 3. Give me negative 33 over 8. The last one, I get 7/4 times 4 over 1. And that gives me 28 over 4, which equals 7. If you notice that you can cross reduce here, that these 4s can cancel out and give you 1s, that can make your life a little bit easier. That could have happened here between the 9 and the 6. But if you don't notice it, you just try to notice it at the end. For division, we follow a similar strategy, but there's a little bit of a difference. So the first thing is still mixed to improper. Step 2 is going to be my, I've heard it as keep change flip. And if you notice something else, I'll talk about it in just a second, but that's kind of my second step. And then multiply and simplify if you need it. Okay. So what we like to do when we multiply fraction or divide fractions is turn it into multiplication. On my first one, I do need to do a little bit of work. I have 1/4 divided by, that's going to be 11/6. And I want to keep the first one, change it to multiplication. So I keep the first one, I change it to multiplication, and I flip the second fraction, 6 over 11. And then I would multiply. 1 times 6 is 6, 4 times 11 is 44, and both of those are even numbers, so I should reduce them, divide them both by 2, and I get 3 over 22. Okay. On my next one, I have 3/4. I'm going to switch it to multiplication, and I still want to flip this, but you notice there's really nothing to flip. Well, there is, because this is a negative 4 over 1. And so I'm going to write it as negative 1 over 4. I leave the negative in the top just because it looks better. But what I get there is negative 3 over 16 when I multiply. Okay. Same thing here. We got a little bit of rearranging to do. That's going to be 9/5. We've seen these ones before. And I'm going to write it as division, even though I'm going to change it in a second. This is going to be negative 6 7/2. So I'll do my keep change flip, negative 9/5. Keep that one. Change it to multiplication, flip the other one. Leave the negative in the top. And negative 9 times negative 2 is 18. 5 times 7 is 35. This one, same idea, it's just written weird. This is basically saying 1/3 divided by 3/7. So all you have to do is rewrite it that way and then do the same process. I keep change flip, and I get 1 times 7 is 7, 3 times 3 is 9. Now, one last time, pause the video, try the problems below. Okay, hopefully you had a chance to get those done. In the first one, we have 3/4 divided by 5/4. And then when I keep change flip, I notice that I have a 4 on the bottom and on the top. So those actually cancel out, and I just have 3 times 1 over 1 times 5, or 3/5. The second one, I've got that whole number as negative 7, and that's negative 7 over 1, which I can flip over and give me negative 1 over 7. So I get negative 2 over 35. The third one, kind of the hardest one of the bunch here, just because the numbers got a little bit larger, but the process remains the same. I get negative 13 fifths divided by negative 23 sixths. I keep, change, flip, and nothing cancels out, even though, we wish it would. But when I multiply those, I get 78 over 115. And on the last one, 2/3 divided by 5/3, that's how you want to write this. And keep, change, flip. Again, I see I have a 3 on the bottom and on the top, and those can cancel out. 2 times 1 over 1 times 5 is 2/5. So that's it for today. A little bit longer of a day, but still doable. At this point, make sure you get the assignments. You should be able to do assignments 3 and 4 at this point, as well as the application that follows this. Have a good day, and we will see you next time.